This is a telescope in the making. It's almost ready. The only thing missing here is the reflective coating. Once finished, it will actually be a complete Schmidt-cassegrain telescope, be it a very tiny one. But what is maybe more remarkable than its modest size is the fact that it is made of one single piece of glass. Today we are going to meet up with the inventor and maker of this type of telescope. It's Rick ter Horst, who is an optical engineer at Nova Astron. Rick is one of the few people who have mastered the craft of making optical components to near perfection. And in a world where optics is mainly mass-manufactured, he is actually still making these tiny monolithic telescopes completely by hand. Of course, I'm very curious to see how he does it. Rick lives in the northern part of the Netherlands, and it's quite a drive, especially in today's Dutch weather. But this gives me the opportunity to give you a bit of general background information about telescopes before we meet up with him. *** about telescopes and focal length ***. Telescopes come in different varieties, but in essence they all have one thing in common. In order to achieve a very high magnification, they need to have a long focal length. This is because the focal length determines the size of the projected image. A lens with a short focal length, like for example the lens in your eye, creates a relatively small image in the focal plane, in this case on your retina. A lens with a longer focal length will create a larger image in the focal plane. So, if we had bigger eyes and the same type of retina, we would actually able to discern smaller details in objects. But a sharper image can also be achieved with more photoreceptors per area in the retina. This is the case for the eagle. Believe it or not, but the eyes of an eagle are the same size as human eyes, and they up a large part of their skulls. But eagles can see smaller details because their retinas have a photoreceptor density which is 5 to 6 times higher than that of humans. The bottom line is that, if we have two optical elements with different focal lengths and we place for example an identical CCD sensors in both focal planes, we will be able to discern smaller details in the image of the lens with the longer focal distance. Because the detail level will very likely be limited by the pixel resolution of the CCD, and not by the lens. A long focal length is also the reason why early telescopes had a long linear construction. And an extreme example is found in the Yerkes telescope in Williams Bay, Wisconsin, which contains a lens with a focal length of more than 19 m. Now, even though you can achieve a very high magnification in this way, it is obviously not a very practical instrument. For example, we need an elevator to move the floor up and down in order to look at the sky under different angles. But luckily there is a way around making ever longer telescopes to achieve a higher magnification, and that is to fold up the optical path. By using a specific combination of curved mirrors, we can make a system that effectively has the same focal length, but is much more compact. And this principle is found in almost all the large modern telescopes, because it allows for increasing the telescope's aperture and focal length, while at the same time keeping the size of the telescope itself relatively limited. The Cassegrain telescope ***. One of the most widely known folded telescope designs is the Cassegrain telescope, named after Laurent Cassegrain, who published this design already in 1672. His design is actually based on a mathematical model for light that enters the telescope exactly parallel to the optical axis. Under these conditions all light will be focused perfectly into a single point. But this design has a few limitations. Light entering under an angle will not have the same perfect projection, because the image field is actually curved and we observe coma when we move away from the optical axis. On top of that, the optical model that the Cassegrain is based on requires the reflective surfaces to be aspherical. The primary mirror is a concave parabola and the secondary mirror is a convex hyperbola. And later in the video we will see that these types of surfaces are relatively difficult to manufacture. So, since the invention, many improvements have been made on the initial design of the Cassegrain. The Schmidt-cassegrain telescope ***. And one of these improvements is the addition of a thin corrective lens called a Schmidt plate. Apart from correcting for the field curvature, this lens allows for the use of a spherical primary mirror, instead of a parabola, which greatly simplifies its manufacture. As a bonus, the Schmidt plate can be used to mechanically hold the secondary mirror in place. And due to this relatively simple construction and excellent image quality, Schmidt-cassegrain telescopes have gained a high popularity among both amateur as well as professional astronomers. Asterisk asterisk the monolithic telescope concept asterisk asterisk. So, after all of this background, we have now come to the essence of the monolithic telescopes. Consider the conventional Schmidt-cassegrain telescope like depicted here schematically. It consists of the optical elements, the Schmidt plate, the primary and secondary mirrors. And apart from the optics, we need a tube to hold everything together. We need the mounts for the mirrors and we need a baffle for blocking stray light. Now the sheer genius behind the concept of the solid telescope is that we can get rid of everything you see here. What we can do is just replace the space between the optical surfaces with glass. And by giving each of these surfaces the right shape and reflectivity, this single piece of glass is equivalent to the complete optical and mechanical system of a Schmidt-cassegrain. Even things like baffles can be incorporated directly in the glass. And we have a bonus optical surface here, which is not present in the standard Schmidt-cassegrain. And this surface can for example be used for additional field corrections. We are almost there now, and I'm pretty excited about this visit. This is actually the first time that I do an interview in a video, and for Rick this is also a first. So in the beginning it will probably be a bit uncomfortable.